Alright guys, we are looking at section 7.4 part 2, and one thing we're going to start off by looking at is a complex fraction. And a complex fraction is a fraction that contains a fraction in the numerator and or the denominator. So if you were asked to do this problem, what would you do? I think a lot of you might grab your calculators. You know, you might do 2/3. I showed you how to do that fraction on your calculator. If you go here, you could do 2/3 plus 1/2. This is even hard to just type in. And then divided by, and I can go back to that, 1/3 minus 3/2. Oops. Okay. And so I get my answer. It's -1. Great. Well, that took us an awful long time to do. Now, I think others of you might say, oh, I'd get a common denominator here and a common denominator here, get this answer, and then do this answer divided by that answer. That's fine too. But let me show you the best and most efficient way of doing it. What is the common denominator for 3 and 2? 3 and 2. 6, right? So I'm going to multiply the numerator by 6 and the denominator by 6. When I do that, I'm multiplying by 6 over 1. So 6 times 2 is 12, divided by 3 is 4, plus half of 6 is 3. Now I'm going to do this in the denominator. 6 times 1 is 6, divided by 3 is 2, minus 6 times 3 is 18, divided by 2 is going to be 9. And so now I've got 7 divided by -7, and I have my answer of -1. I really think that's even faster. All we did again was we looked for this common denominator of all of the denominators and then multiplied by 6 over 6, because that was the common denominator, the least common denominator. And so when we do that, all we're doing is multiplying by 1. It doesn't change the value. So we're going to try the same thing on another problem. So here's method 1. If necessary, simplify the numerator and denominator by writing each as a single fraction. Then divide by multiplying the numerator by the reciprocal of the denominator. And that's what I was saying up here, how a lot of you might think of it. You would get this answer, what is this, 4/6 plus 3/6 divided by, and this would be 2/6 minus 9/6. So then this is 7/6 divided by, and this would be -7/6. So then we can do 7/6 times this reciprocal, and then that's going to give us -1. But I really think this way will be faster once you get the hang of it. So the second way is to multiply the numerator and the denominator by the least common denominator of every fraction in the numerator and denominator, then simplify. I'm telling you it's faster. If you want to race me, you guys can do method 1. I'm doing method 2 right here. My common denominator with 2, 4, and 3 is going to be 12. So I'm multiplying the top by 12, the bottom by 12. 12 divided by 2 is 6 times 1. 12 divided by 4 is 3 times 3. 12 divided by 3 is 4, times 2 is 8. 12 times 1 is 12. My answer is going to be -3 over 20. Are you finished yet if you use method 1? Probably not. If you use the calculator, you're probably not finished. And guys, if you don't understand how to use that fraction thing like I showed you, it would even take you a longer amount of time. You got to do parentheses 1/2 minus 3/4 divided by parentheses 2/3 plus 1 parentheses equals this. Then I have to math frac that. And finally, I get my -3/20. I'm telling you, it's faster the way I'm showing you. Try to embrace it. All right, simplify the complex fraction. Remember to write restrictions if necessary. Looking at the beginning here, x cannot equal 0, or else I'm going to be dividing that by 0 and have an imaginary number. Or sorry, dividing that by 0 and having undefined value. So I'm going to multiply through by that common denominator of 10x here and 10x here. So then I'm going to distribute. So I'm going to have 10x divided by 10. Well, that's going to be x times x is x squared. Then I have 10x times 3. That's 30x. Down here, 10x times 5, that's 50x. 10x divided by x, that's going to be just 10. So now I'm going to factor out an x, so x times x minus 30 over, here I'm going to factor out a 10, and that's going to give me 5x plus 1. So now I'm just going to see if I can do any canceling. So when I look back here, just checking this out, okay, nothing's going to cancel, is it? And so this is just going to be our answer right here. Now, one thing I have to keep in mind is at the beginning, x was not allowed to be 0. But here, if I plug in 0 for x, I'm just going to get 0 as my answer. But here, the function was undefined when x is 0. So I would say this is my answer, but I would also have to make the restriction that x cannot equal 0. Because back here, that was my domain, but that's not my domain here. Here, I'm saying x couldn't, the domain would be x not equal to negative 1/5. All right, let's look at the next one. We have 12 over, I'm going to factor this. This is x and x. We always want to have everything factored. So numbers that multiply to be 44 and subtract to be 7 are 11 and 4. This would be subtract, this would be add. Then down here, I'm going to just have 2 over x minus 11 plus 1 over x plus 4. The common denominator, I have to use all of this. I already used this, so I don't have to use it again. And then I already have this one, so I don't have to use it again. So I'm going to multiply the top and the bottom by the least common denominator, which is what I'm writing. And now I'm just going to multiply. So if I have 12 times all of this over this, everything cancels. So I'm just going to get 12. And then on this one, when I distribute through here, x minus 11's cancel. So on just this term, I would have 2 times x plus 4. Okay, now pretend I didn't mark that out because now I have to distribute to here. So on this one, the x plus 4's would cancel, so I would have plus 1 times x minus 11. Now these are not factored, so I have to simplify it. I'm going to have 12 in the numerator, then I'm going to have 2x plus 8. I have to combine these like terms, so I have to multiply it out first. So I'm going to get 12 over 3x minus 3. That goes to 12 times 3 parentheses x minus 1 in factored form. But look back at the beginning. Back at the beginning, x could not equal 11 and x could not equal negative 4. Well, now those numbers would be fine, wouldn't they, in the simplified version? So I have to say that. This is equivalent to this, but you can't let x equal 11 and you can't let x equal negative 4 because it was undefined back here, and here we would get just some normal answers. All right, let's come over here. All right, it says to rewrite f of x equals 3x plus 5 over x plus 1 in the form f of x equals a over x minus h plus k. All right, what I'm allowed to do is, this is not a complex fraction. This is a different kind of problem. I could separate this out. Isn't it true that 3x over x plus 1 plus 5 over x plus 1, isn't that the same thing as this? See, if we have a common denominator, we would just add the numerator. So these are equivalent. I could break it up like that, but it's not helpful. See, I want to be able to break it up, but I want one of them to have x plus 1 as its denominator, meaning x minus h, and then I want the other one just to be a whole number. And this is going to come in handy later on when we do some graphing, and that's why we do this. So what I'm going to do is I'm going to rewrite 3x plus 5. Watch how, and I want it to be able to cancel with this, so I'm going to rewrite 3x plus 5 as 3x plus 3 plus 2 all over x plus 1. Check it out. Isn't that equivalent? The reason I did this is because now out of these two, I can factor out a 3, and I would have x plus 1 plus the 2 all over x plus 1. This is one of my terms. This is my other term. So this is equal to 3 times x plus 1 over x plus 1 plus 2 over x plus 1. See how that makes sense? I'm putting this is one term right here. I mean, there's two terms there, but this all goes together, over x plus 1 plus 2 over x plus 1. So now these are going to cancel, and so I'm going to get 3 plus 2 over x plus 1. Look at the way they want me to rewrite it. So I'm just going to switch it. So it's going to be f of x equals 2 over x plus 1 plus 3. All right, let's try the other one now. So on the other one, I'm trying to do the same kind of thing. So I've got to rewrite this. Right now I could put 2x over this and 4 over this, but that's not going to help me. Somehow I need to get, if I think about 2x to be able to factor the 2 out and get a 3, I need to have 2x minus 6. See how if I have that, then I could end up factoring out a 2 and get the x minus 3's to cancel? So what I'm going to do then is I am going to rewrite 2x minus 4 as 2x minus 6, but then I'd have to add 2, right, to keep it equal to what it truly is. So now I can do 2x minus 6 over x minus 3 plus 2 over x minus 3. Don't you agree that's the same thing? See, 2x minus 6 plus 2 all over that. So that's going to become, right here, I'm going to factor out the 2, and I've got x minus 3 over x minus 3 plus 2 over x minus 3. So now these would cancel, so my answer is going to be then, they want it in this kind of form, so I'm going to have 2 over x minus 3 plus 2, and that's equivalent to the original function. Now, let's say you're having trouble with that. Here's another way you could do it. Think of how we can divide these. We can use synthetic division, right? What's going to make this equal 0? 3. Good. If you prefer, I could use synthetic division. Bring this down, that's 2. 3 times 2 is 6. Subtract, I get 2. So the answer is going to be just 2 plus 2 is my remainder over x minus 3. Do you like that way better? If so, you can use it. Let's go back up here and do this one with synthetic. What would make this denominator equal 0? Good. So put -1 in the box. 3 and 5 are in the numerator. Bring this down, that's 3. That's going to be -3 added, that's 2. And so that means that 3 is my answer. 3 is the answer. But I also am going to have plus this remainder that's going to get put over the x plus 1. So you might like doing it better that way. Okay, I want you to do these two on your own. I want you to pause the video. OYO is on your own. Pause the video right now, try them, and then come back and check your answer. I'm not going to talk you through these. I'm going to do this one 2 different ways just to show you. All right, so go. Stop the video. Or I could have done synthetic. So then I'd have 6 as my answer. Then I'd have -26 over x plus 5. And then I would just turn it around so it's in that kind of form. Same thing, okay? I need to put g of x equals on these, or whatever they tell me to call it. Okay, hopefully you've already done this one. I'm going to do it. Remember, you got to be an active learner. Just watching doesn't cut it. You got to do it on your own. Common denominator, x plus 1, x minus 2. So I have to multiply this. X minus 2's would cancel. I'd have 16 times x plus 1. On this one, the x plus 1's cancel. I have 4 times x minus 2 plus, on this one, these would cancel, 5 times x plus 1. This is not factored form. This is addition. Factors means I don't have only multiplication. The top I don't need to mess with. It is in factored form. But the bottom, a little bit further. Nothing cancels out there. Okay, so I'm going to have to just leave it like that. But I have to look back at the beginning. At the beginning, x could not equal 2, x could not equal negative 1. Is that still the case? No. If I plugged in 2, I'd get a nice answer. And if I plugged in negative 1, same thing. So I have to say this is equivalent, but not when x is 2 and not when x is negative 1. Hopefully you remembered those restrictions. If not, make sure you understand why. And that's it. So the two big things we're talking about is how to do this rewrite. We can either do it with synthetic division, or we can do it by just keeping equivalency. Okay? And then the other thing we talked about was simplifying complex fractions. We're multiplying through by the least common denominator of all the denominators. When you're finding these restrictions here at the end, you got to check that domain at the beginning, because that's what makes that undefined at the beginning. But if it doesn't make it undefined at the end, then you've got to make sure that you put that in there. All right.